The James Webb Space Telescope, one of humanity's most advanced eyes in space, recently captured something extraordinary. This discovery on Mercury, hidden in plain sight near the colossal sun, has forced NASA to take swift and decisive action. What is it about Mercury, the smallest planet in our solar system, that could cause such a response? Once thought to be just a rocky, barren world scorched by the sun, new findings have upended everything we thought we knew. Mercury may be small, but it is far from ordinary. This tiny planet closest to the sun is packed with surprises that continue to baffle scientists. Among these unexpected revelations is the presence of diamonds, believed to be scattered across Mercury's fiery surface. How could such valuable and delicate formations exist in one of the hottest places in the solar system? As we dive deeper into Mercury's mysteries, we uncover even more astonishing discoveries that challenge our understanding of how planets form and evolve. Beneath Mercury's rocky exterior lies an enormous dense core, much larger than scientists initially predicted. This core holds the key to many of Mercury's anomalies, but it also raises new, more perplexing questions. How did Mercury, a planet smaller than Earth's moon, end up with such a massive core? Could it be the result of a cataclysmic event in the planet's early history? Or is there another explanation? One theory suggests Mercury was once a much larger planet that lost its outer layers in a violent collision, leaving behind the dense core we see today. This hit-and-run scenario is just one of many that are now being explored. Our journey of discovery on Mercury began decades ago with NASA's Mariner 10 spacecraft, the first to visit the planet. Mariner 10 gave us our first close-up look at Mercury, revealing a cratered moon-like surface and providing the first clues that Mercury was more than just a dead rock in space. Among its many surprises, Mariner 10 discovered that Mercury had a magnetic field, something completely unexpected for a planet its size. It also hinted at the presence of a much larger core than previously thought, but the full extent of these revelations would not be known for another 30 years. In 2004, NASA launched the Messenger mission, designed to orbit Mercury and provide detailed long-term observations. Messenger's data revolutionized our understanding of the planet. The spacecraft revealed over 200,000 images of Mercury's surface, uncovering areas we had never seen before and giving scientists an unprecedented view of its landscape. The discoveries didn't stop with photographs. Messenger's instruments also detected unexpectedly high levels of elements like calcium and magnesium, particularly on the darker side of the planet. These findings raised new questions about Mercury's geologic activity and how such elements came to be present in such abundance. Mercury's magnetic field, another of Messenger's key discoveries, proved to be even more unusual than initially thought. While Earth's magnetic field is relatively uniform, Mercury's is far stronger in its northern hemisphere than its southern hemisphere. This irregularity suggests that Mercury's internal structure and the processes that generate its magnetic field are highly unique, setting it apart from other planets in the solar system. On Earth, magnetic fields are generated by the movement of molten iron in the core, but Mercury's core behaves differently due to its size and composition. These differences point to an internal dynamism on Mercury that scientists are still struggling to fully understand. The environment on Mercury is extreme, to say the least. During the day, surface temperatures can soar to 800 degrees Fahrenheit, hot enough to melt lead. Yet at night, the temperature plummets to nearly -300 degrees Fahrenheit. This massive temperature swing is due to Mercury's thin atmosphere, or more accurately, its exosphere, a faint layer of particles that can't retain heat. Despite these punishing conditions, Mercury has shown signs of volcanic activity, challenging earlier assumptions that the planet was geologically inactive. In 2012, Messenger detected evidence of explosive eruptions in Mercury's past, and in 2020, new research indicated that volcanic activity might have been more recent than previously believed. Perhaps the most shocking discovery came from Mercury's poles. Despite its proximity to the sun, areas near Mercury's north and south poles, specifically in craters that are permanently shadowed from the sun's rays, were found to contain water ice. The idea that a planet so close to the sun could harbor ice is difficult to fathom, yet there it is, preserved in the eternal darkness of these polar craters. The existence of water on Mercury raises tantalizing questions about the planet's history. Could Mercury have once had conditions that were more conducive to life? Is it possible that life forms, similar to extremophiles on Earth, could exist in these icy pockets? The upcoming BepiColombo mission, a joint venture between the European Space Agency and the Japan Aerospace Exploration Agency, is expected to shed more light on Mercury's mysteries when it arrives at the planet in 2025. BepiColombo will gather even more detailed data about Mercury's surface and geological history. As we look forward to BepiColombo's findings, we are left to wonder what new secrets will emerge from this enigmatic world. Despite its small size, Mercury's complex interior, magnetic field, and history of volcanic activity hint at a planet far more dynamic than we ever imagined. One of the most bizarre aspects of Mercury is its day-night cycle. Mercury's day is longer than its year, 176 Earth days for a single rotation, compared to just 88 Earth days to complete an orbit around the Sun. This creates a situation where, if you were standing on Mercury, you would see the sun rise, move across the sky, stop, move backward, and then continue forward again. This strange behavior is due to Mercury's unique spin-orbit resonance, which causes it to rotate 3 times for every 2 orbits around the Sun. The extreme heat on the side of Mercury facing the Sun and the freezing cold on the side facing away create some of the most dramatic temperature variations in the solar system. Mercury's lack of a substantial atmosphere also has a profound effect on the planet's surface. Without an atmosphere to protect it from solar radiation and impacts, Mercury is constantly bombarded by solar wind and space debris. These impacts create a thin exosphere, primarily composed of oxygen, sodium, hydrogen, and other elements that are constantly escaping into space. In 2020, new data from Messenger revealed that Mercury's exosphere contains more water vapor than previously thought. This discovery has led scientists to speculate about the processes that could be responsible for releasing this water vapor into the exosphere. Another factor contributing to Mercury's unique environment is its magnetic field, which, although much weaker than Earth's, plays a crucial role in protecting the planet's surface from solar wind. Scientists are still investigating how Mercury's magnetic field is generated, given the planet's small size and slow rotation. One theory suggests that the movement of liquid metal in Mercury's core, influenced by its unusual spin-orbit resonance, is responsible for generating its magnetic field. This has led researchers to reconsider how magnetic fields form not just on Mercury, but on other planets as well. Mercury's chaotic landscape adds to its mystery. In particular, an area near the southern pole known as the chaotic terrain is marked by hills, valleys, and ridges that seem to have been formed by massive quakes, likely caused by the Sun's gravitational pull as Mercury's orbit changed over time. These quakes may have played a significant role in shaping Mercury's surface, but they also point to deeper internal processes that scientists are only beginning to understand. One of the leading theories is that these quakes are linked to Mercury's cooling and contraction over billions of years, as the planet's core solidified and its crust buckled under the pressure. Recent studies have provided new insights into Mercury's internal structure. It is now believed that Mercury has a liquid outer core and a solid inner core, much like Earth. However, Mercury's inner core is proportionally much larger, making up about half of the planet's total volume. This could explain some of Mercury's unusual magnetic properties, as well as its geological activity. Unlike Earth, where tectonic plates are constantly shifting and reshaping the surface, Mercury's surface shows evidence of contraction, large thrust faults that indicate the planet has shrunk as it cooled. These faults are some of the most visible signs of Mercury's ongoing geological activity. Despite its intense heat, Mercury's surface contains elements that scientists never expected to find. In 2020, researchers discovered volatile elements like sulfur, potassium, and sodium, substances that typically vaporize at high temperatures. This has raised the possibility that these elements were delivered to Mercury by comets or asteroids long after the planet formed. The presence of these materials challenges our understanding of how planets close to the Sun evolve and retain volatile compounds. One of the most intriguing questions raised by Mercury's recent discoveries is whether the planet could have ever supported life. While Mercury's surface is currently inhospitable, with temperatures that swing from one extreme to another and no substantial atmosphere to speak of, the discovery of water ice and organic materials in the planet's polar regions suggests that there may have been a time when conditions on Mercury were more favorable. Scientists are now exploring the possibility that Mercury's icy craters could harbor life forms similar to those found in Earth's harshest environments. These extremophils, capable of surviving in extreme cold and without sunlight, offer a model for what life might look like on other planets. Understanding Mercury's geological history and internal structure also has important implications for the study of other rocky planets, including Earth. By studying Mercury's core, mantle, and crust, scientists can gain insights into the processes that shape not only Mercury, but the other terrestrial planets as well. For example, Mercury's core makes up 85% of the planet's total volume, far more than the core of Earth or Venus. This has led researchers to hypothesize that Mercury's formation was influenced by different factors than those that shaped the other inner planets. If Mercury was once a larger planet, as some scientists believe, then it may have lost much of its outer layers in a massive collision early in its history. This would explain why its core is so disproportionately large compared to its mantle and crust. Mercury's surface is also a valuable record of the solar system's history. The planet's craters, some of the oldest in the solar system, offer clues about the early days of planetary formation and the processes that shaped our celestial neighborhood.